There is a solver. There's a little fishy too that I found somewhere.
Oh, there's a fish. Yeah.
So those little fishies stay up in there and what's legend? But this. Yes.
I'll just get that so everyone can see that. I just want to make sure that everyone can see the bots. That would, and Adam's brought a little bit of a demo here on the table. So I don't know if you can actually see what's going on. Was there any other coming in on there, Crancy?
It's still booting up. I'll see what happens. No, it's starting. It'll work for 3 days. And as soon as you bring it in, it'll stop
Of
later.
course. That's the way it works.
See what happens. All right, how's that timing going?
Yep.
Good. Come on, do your thing. Yes.
Yay!
Lights come off. Quick.
Lights coming on.
Okay, shut up.
Action.
Had quite a few failures today already, so everything that works is a big win for me today.
Actually capturing, yeah, so they're just asking around the AI, and what is actually there as a computer vision, and
So the last sort of 10 minutes of my talk is all about this and what it is and sort of what's going on. But to give you just a heads up on what's going on, this is just a very, very basic setup to show how easy it is to do AI image detection and do stuff with that knowledge, basically. So this is where all these robots are going because stuff has been released in the last few years that miniaturizes everything. So normally if you do AI image detection, you need like a big laptop, you need some big power systems. And you generally have to write a lot of code, a lot of OpenCV. Has anyone heard of OpenCV? Yeah, that's kind of basic with image stuff. A long list of stuff. If you've ever played around with it, it's very, very difficult, very, very hard. And so what I wanted to show you guys today is that there are other alternatives out there of how you can do that same thing, but utilizing the work of someone else and graphic user interface. So what this is in a nutshell is a Raspberry Pi. We know what a Raspberry Pi is?
Delicious, is it?
Delicious, exactly. So hooked up to this Raspberry Pi is two little web cameras. Okay? Two mini USB cameras. They're just on these little things here. I just glued them in. They're the same size as the ones on your phone. They're very, very small. And so that's hooked in. And then the fancy thing is this little thing right here, this silver thing, which I've got hooked up to a USB hub just because it needs a little bit more power. I didn't have the time to solder it in properly. And that's a TPU unit, or Coral TPU. And it's a tensor processing unit, so it's an AI chip, basically. And it's doing billions of calculations every second. And so what that's doing is the software is reading the cameras and then feeding it into that AI chip, and it's detecting different objects and then pumping that out. And so what I've done is I've just hooked it up to a relay board here. And so this light is indicating that this camera sees a person right now. This light is indicating that this camera sees a person right now. And I wanted to choose one other thing that it could detect. You've got a long list of 20 different. Okay, but I put in book as the second one. Anyone got to grab that book? We'll see. I don't know if it's going to work, but if there's a bookshelf right behind you, it triggers up every time. So the other two lights are, does it discover a book in front of the thing as well? Unfortunately, I can only get it to detect like bookshelves. If it was a bookshelf full of books, it would detect it. But here, I might be struggling to to get it to work. If we just put the book here and we'll see if it gets there eventually, but I can guarantee if we cover this one, eventually it will go, hang on, I'm not seeing people anymore. I've got to be careful because it actually will detect my hand and go, that's a person as well. Little things like that.
Steve,
I'll come back in a second.
it's that pop-up bookshelf right there.
That's what's that.
Awesome.
Look what's going on in the back end. But yeah, that's the basic of it. And I'm going to run you through how you can set this up. And it can be set up. You don't need a Raspberry Pi. You can use a laptop and just a USB camera on your laptop, but it can be set up in under an hour. It's very, very fast to do.
Amazing.
Which one's the Raspberry Pi? This one. This one. That one? Yeah. Okay. So it's just a small circuit board.
Motherboard.
And the CPU. Okay. I've heard of people making streamer boxes out of Raspberry Pis.
You can do anything with the Raspberry Pi.
Raspberry Pi.
Yeah. Okay.
Okay, so we've got a few more minutes until we actually officially start, so I'm just gonna go and check to make sure anyone else is heading over. We've got some online here, Adam invited here with me, so just in case anyone backs up on that link, I'll keep an eye on this link. Thank you, Kathy. And we'll start officially in 10 minutes. Yeah.
Much.
Yeah, I love it. Yeah. You can follow. Oh, the which one? What is the store? I follow the Premier League. Premier League. Then in England. Premier. Most famous. In England. You don't follow? Yeah. The German? Which one? You like the language club? Which club? This is the Bayern Munich. Yeah. So you prefer the German one? Yeah. I prefer in England. Yeah, in England, you know, Liverpool, Manchester, yes. Especially because some Colombian players, they play the champs. Yeah, James. James right now is a little bit old, but he started playing again in Rayo Vallecano, in La Liga in Spain. Yeah, in Madrid. Yeah. We have a Luis Diaz always there, in Liverpool. That's why I follow. And they have to check when they play. Well, yeah, just you, but this. Very good.
In the same class.
Yeah, qualify for the World Cup. Do shine class. They could no, international, yeah, we have leadership with the. Yes, that's asking for it, but we don't. Sorry, I don't understand. Stop. Oh, it's Sandra. Yeah, oh, she's not here, she's for. And. Oh, yeah.
All right, I think that's it. Adam, I've looked around and we've got everyone here, so that's good to go.
And then we will put this. 1 million. Yeah, unfortunately, the time, time is terrible. We should have a game after.
And if you can just do the quarter.
Okay, this is not bad, for example, on Saturday, 9 p.m. Arsenal, Brighton. So that's good, right? And with this. Stop shaking.
Oh, no, you're sharing that one.
Yeah.
When to use it.
Yeah. They play already only 2 games, you know? And Liverpool. Something difficult. Obviously. Sorry? Obviously,
I'm not the main guy.
I've got 2 recordings going on.
are you married?
Just double checking that all the online guests can hear okay. Just give me a thumbs up, that would be great.
1-1.
Tilly, can you hear okay?
They play only 2 games. Yes. To start the season.
Okay, thank you, Desmond, DJ Desmond. Excellent. Oh, DJ Desi, thank you. Awesome. I'm going to hand the floor over now to Adam. So thank you everyone for attending today's session. And we'll make a start. And this is one of our AI literacy theories. So Adam has very kindly offered, as you know, Adam is the founder of Teleportal and has an incredible background, which he's going to share about his story. And today's session is Navigating the Depths, AI, Robotics, and the Future of Underwater Exploration. So let's give Adam a big round of applause.
Good afternoon, everybody. So as Sam said, my name is Adam, and I'm the founder of Teleportal, a local robotics company. And so what I want to do with this talk today is I wanted to spend about 10 minutes just telling you a little bit about myself and my background and what got me to here. Tell you a little bit about AussieBot and the Teleportal robots as well. And then I want to do that hands-on session where I show you about, oh, that was there for a purpose, but it's all good. The light came on, it's working. So that's show you about this and how you too can simply set up an AI image recognition stack or software to use with whatever you want to use in under an hour as well. And I've got all the links to a GitHub page that gives you all the details and stuff like that. And then making sure we've got heaps of room at the very end to talk, to do some questions and answers, because that's really what I love. I love hearing about your ideas, your questions, your inquiries about AI and robotics, especially marine robotics, and we can have a bit of a chat about that. Okay, sound like a plan? Yeah, that's good. Okay, so my story. Most of my life, I've been a science communicator, working on different ships around the world and in different places, communicating lots of different aspects of science to people. Definitely a technology enthusiast. I'm always into technology and different things coming out. I'm always interested in tinkering with stuff. Self-taught programmer. I learned BASIC by myself when I was about 12 years old, just on the computer at home that I built, and self-taught mechatronics engineer. So I just bought Raspberry Pi and I just started playing around with it. And that's one of the best ways to learn. It really is. Just buy a small little simple computer, play around, see what you can make it do, and go from there. And I found that's given me a lot of heads up, a lot of other people down the road where people are kind of classically trained, where I can kind of jump in and go, oh, I've done that before. I plugged that into the board, I know how to do it. And that goes a long way. So that's a bit about me. Back in 2014, the last sort of science communicator job I had, I was working for Little Out Expeditions, National Geographic, on their ships around the world. And I was working as an expedition leader. And during the start of that, because of that technology enthusiasm that I have, I wanted to bring something new to the table. And so I bought 2 of these quadcopter drones, which kind of, they're everywhere these days. So this is back in 2014. That was the first model ever released by DJI that you could buy. And they had a lot more problems than the current ones. But I used it for scouting. So seeing areas in front, so I could go for a quick fly for 10 minutes and I could go, okay, folks, we've got a whale over there, we've got some sharks over there, we've got a crocodile over there, and could quickly, what would generally take me hours in a small boat to find everything, I could find it pretty much instantly. And then it also allowed us to scout areas that we couldn't see and give that perspective that you generally couldn't see from the ground level. And a good one is up in the Kimberley, in the top northwestern part of Australia. This is Montgomery Reef, the largest inshore reef in the world. And so you can just get that totally different perspective. So that's what drones brought to the expedition field. And I was also working with ROVs as well, these guys, underwater remotely controlled vehicles. And we had one of them on the ship as well, but it spent half its time broken and is 10 times the price of that one. So yeah, lots and lots of pretty shots. I got really into drones and how to build them and all the aspects behind them. And what I think is lost on most people is that aerial drones, underwater drones, the drones that go on the ground, they've all got the exact same technology stack in them. It's just a software thing that you flick between an aerial drone, underwater drone, and all that. So once you learn the technology of one, it can be used what we call multimodal or across air, land, and sea, wherever your drone might be. And just to finish off this one, I also got a permit to work in Antarctica as well. So I was the first person to fly drones that weren't scientific, that were more for, I wouldn't say recreational, it's more professional, but down in Antarctica as well. And that was really mind-opening to see kind of the expanses and different stuff that you could see down in Antarctica from the drone. It really opened up the perspective of what you could see down there and what was just over the hill that you've never seen before, even though you've been there 100 times. And brought on a lot of really narrowed my skills for drone flying as well, because you're operating minus 20 degrees, minus 30 degrees. You suddenly will go from 0 wind to 70 knots instantly. And you're flying from a little tiny boat, a little rubber ducky boat. That's what you're flying from. So if anything goes wrong, that drone is going to go and land, return to home, but where its home was doesn't exist anymore. It's just open ocean, and it's going to land in the ocean. So you're really going to be on the ball when you fly in really challenging environments like this. But I reveled in it. I really liked it. Lots of amazing experiences. And so that's kind of the science communicator side of me. And then what happened working there for 5 years is I discovered that getting ocean data is really expensive. And we would get a lot of ocean data on these ships. But when you talk to all these hundreds of researchers and ocean researchers over these years of working on it, you can see that the majority of their science budgets just go for renting a ship to get to there to do a water sample or whatever they want to do. It's like $100,000 per day just to get a water sample or something like that. And it was just, I wouldn't say a waste of money, but it was just very inefficient. And that's when I came up with this guy. This is AussieBot. So I decided, hey, why don't I take all this technology and these concepts that I have and put them into an autonomous boat that could go out there and do that research and do the same research that costs $100,000 a day, but do it every day. And do it all for the same price of that $100,000 for the whole entire unit. And so I can see huge different savings here. So while I was still working in National Geographic, like all startup founders, I built this in my mum's garage on my time off. I just went there, spent a few days every month off and built it. It's quite a decent size. It's 5 meters long, 1.5 meters wide, 2 meters high with the mast, about 300 kilograms, and it draws, the depth underneath is about 0.7 meter. Made with fiberglass with a honeycomb support in the middle. And the idea of it was to have this unlimited range. The only thing that's restricting it is marine growth, stuff growing on it. Speed, very slow, solar power, 2 knots. It's just going a little bit faster than the current. Two 12-volt motors in there, about 400 amp hours of batteries, about a kilowatt of solar on top. And then it was controlled with a Pixhawk. Has anyone heard of a Pixhawk before? No? Okay. A Pixhawk is basically a little tiny unit. We'll talk about it a little bit further down. That is a autopilot. It's the brains that controls where it's going. And then it communicated via satellite, via the Iridium network, back to us. And it's just a text message network. So we would get messages back, hey, this is where we are, this is how much battery we have, that sort of stuff. And the communication stack and how that all operates was a bit of a pain in the ass to set up back in 2014. Now there is just endless open source ones that you can copy and paste. We had to build it ourselves. GPS, and then the payload up in the mast was a Raspberry Pi, a little single board computer, a little USB camera, just like this one here, and it was taking a picture every 2 minutes, and it could do that for 2 years. And so that was the initial payload that we were taking out of. So its mission, this is 2000, by the time it took me about a year to build it in Mum's garage, and so we're talking about 2019 now, just before COVID. And this was its mission. We were launching from down near Coffs Harbour, a place called Southwest Rocks, and we were going across, this is New Zealand there, going across the top of New Zealand, and then going basically around Antarctica and then coming back. So that was the mission that we set out for this. And the thought behind it was actually test it to destruction. We're just going to send it out and see how long it goes before it gets destroyed. And then we'll know how reliable it is, how much and what we can do to change it kind of further on. So that was its original mission. We launched on the 8th of July. I drove it down the coast there. A friend of mine helped me put it in the water. We drove it out as far as we could, and then we let it go. And watched it go off into the sunset. It was quite an emotional thing. We spent by then about 2 years building something, and then just a year later. And it did really well. Over the first 2 weeks, it came out this way, and it was perfectly on track. The track coming up here is because of this giant thing. It ended up, you could predict about a week in front, so we knew we had a week of good weather, and then sure enough, a week later, or about 2 weeks later, a giant storm came in. This was like, 10-meter waves and 60 knot winds. It was huge. But it did survive that storm. And we were really, really impressed. It couldn't do the track anymore. It was getting blown off course a bit. But you can see once the weather got good, it kind of turned around and started to go back to where it was needed to go. Unfortunately, at this stage, it ran into something out here. And what it ran into was this, a boat called the Assassin. Yeah. So this is a long-range fishing boat that's working off just south of Lord Howe Island over here. And AussieBot had AIS, or a beacon that sort of senses, and this boat has a beacon as well. That's how we could tell that they came together. They didn't actually come together as per se, they came close to each other, and then this boat turned off its tracker and then headed straight for it, and then turned on its tracker after it left. But you could see it basically turned and gone and checked this out. And we went, okay, we went and checked it out, that's all fine. But unfortunately, over the next 2 days, the battery level just kept going down. The battery level never kept going up. And its communications went further and further in between. It was meant to go every 30 minutes. We only started getting them every few hours. And then eventually, the final message it sent was low power, shutting down, and we never heard from it. That was it. So yeah, 2 weeks of 2 years of work, building it all, putting it out there, 2 weeks, boom, never heard from you. And I moved on. I started building these guys and started doing other stuff. I left behind, for any of those who are an entrepreneur in the room, I left behind what will soon become a multi-billion-dollar industry and moved over to something else that no one's copied yet, no one has anything to do with. I'm still the only one in the world. Remember that one. But anyway, 994 days later, I get an email. Yeah, fishermen down on Newcastle had spotted it, and it had report@aussiebot.com on it. So he sent me an email and said, hey, is this yours? I was like, yeah, it is. And so my brother, because my brother's down in Sydney, he went and rescued it off the beach and pulled it up, and yeah, And so what it had done, as you can see, it doesn't have any marine growth on it. It's totally clean. And so that enabled us to deduce actually where it had gone. Because this original track, it was following the currents. That's all it was doing. So it had a little bit of power and it just pushed itself back in the current, but technically the current should push it all the way around here. And so that's exactly what happened. Even though it shut down and we didn't hear from it again, it continued its mission and went right the way around and came back up. The reason we know that is because there's no marine growth on it. If it had gone further higher than this, it would have marine growth on it, it'd be filled with stuff. But in the cold Southern Ocean, it can't have any marine growth on it and it would be clean. And everything in the Southern Ocean goes this way. If you plop anything in here, you're guaranteed it's going to come here because that's the way all the currents go. So we pretty much guaranteed this is where it went. So it actually did its mission over 3 years. We just didn't know about it. So moving on, since that guy came back, it's kind of inspired me that, hey, I'm going to do another one of these. And so this is Aussiebot 2 Patrol. Same size, 5 meters, but made out of aluminium, fully designed, and we've just been trying to get funding for it for the last year because this is beyond what my budget can do out of my pocket, and so we're just still trying to get the funding to be able to build a full-size version. And unfortunately, we're moving away from research and moving towards more military because research just doesn't have the money to do this or doesn't want to put money into it. But military, they're in love with this thing. It's going to get money out of it. So that's where we're going next. And this is electric and diesel at the same time. So it's a hybrid of the two to give it a lot more oomph, basically a lot more range. All right. So while the boat was going around Antarctica and I had no idea, I moved on to teleportal, which is a great way, let me just check the time, is a way to open up the Great Barrier Reef to people who have never experienced it before. So I had a diving accident back in 2012 when I can't scuba dive anymore, and this was the way I could go scuba diving again. And I had a lot of fun, and I realized a lot of other people probably be in the same situation who would like to explore the Great Barrier Reef but can't. And that's where teleportal came in. Totally solar powered, eco-friendly experience, and it also has the sonar on there as well, sonar obstacle avoidance system. And so that is constantly pinging out sound in front of it, and if it gets within a meter of an object or a fish, it pulls back away and pulls away from it. So users can do it quite easily and have a lot of fun. And people have been on all day today, kids in children's hospital, and they haven't caused any damage to the reef because we have that system in place. So believe it or not a technically hard thing to do. What was technically hard about it was that I started doing this in 2019 and 2020, and this was before ChatGPT. So I had to work out the whole software stack and learn how to code it all and all that sort of stuff. I had to use Stack Overflow. Does anyone know what Stack Overflow is? What? You are so lucky you have no idea what Stack Overflow is. You are so lucky. So before we could just type in ChatGPT, how do you do this, and it would explain it all, we would have to go to these forums, Stack Overflow, and we'd have to search for someone who had the exact same issue and read through hundreds of pages of text to try to work out how to do it. And it wouldn't be exact, and you have to do a lot of trial and error. And now you've got ChatGPT, and it just helps. So if I had to do this today, it would be about 1/10 of the time to build it. But the other big part of it, I said the software is actually quite reasonably easy. The biggest part was reliability. Having one of these things floating out here, these are only designed to be put in the water for a couple of hours and taken out again. They're not meant to be in the water continuously. And I have these 2 weeks at a time in the water out there. And so reliability was a big thing. That's what took us probably about 2 years to work out, is just, hey, what part breaks? How can we replace that? How can we improve it so it doesn't break again? And keep doing those things to the point where we have something that will run for thousands of hours in between servicing. We started off mainly with schools and the general public. There were our two main target markets as we were started. And it went very well. Had a lot of really great feedback from schools. They really loved it. And general people around the world were using it as well, which was great. And then we were incredibly lucky to team up with a partner, because at this stage I had a small little yacht, 7 meters, and I would drive that out. It would take me 4 hours to drive it out there. I'd set the robot up, and then I'd drive back for 4 hours back home, and I had the yacht out there for a month or so, and I'd be constantly looking at the weather, and if the weather got bad, I'd quickly run out and have to grab the yacht, and it was quite a lot of work to maintain that. But then luckily, Albert from Celsi, one of the founders and residents here, he approached me and he said, hey, we've got this platform out at Green Island here, and this is during COVID. No one's using it. It's just sitting there. Do you want to use it? And I went, yes, that would be amazing. So I set my robots up on this, formed a partnership with Quicksilver, and then we got this lovely Green Island dive site, which is amazing. And it's hard to explain to people. The reason this dive site is so good is because it's got all these tame fish there. So it's got a turtle that hangs out there all the time. It's got all these tame fish. There's a lot of really interesting stuff to look at, even though it's only a very small dive site. And so that worked out really, really well. And then I almost wasn't going to put this slide in here, but I knew there'd be a few of the founders here and entrepreneurs. And I wanted to just point out that it's not all smooth sailing. Although I don't think my story's been talking too smooth sailing up until this point, but there is things that are going to stop you that you don't expect. Okay, so I came in the teleportal. I knew I had a lot of life savings that I was going to put forth. I had a decent amount of money, I had a decent amount of time, and I thought I could do it, but you never expect things like the red tape to come in sometimes. So with teleportal, we're the first and only person in the world doing this, so we had to obviously cover a lot of red tape, and mainly trying to find catch-22s in that red tape to operate in. Because when you go forth for something like this, the government turns around and goes, yeah, that's not a problem at all. You put $1 million vessel above it and you pay us $20,000 a year for all the bureaucracy and the red tape and stuff, and you put someone on it 24 hours, you can do whatever you like. And obviously that wasn't going to work for us because this was a much more lower scale thing, and we wanted to be completely automated and not have someone out there. And so we went through loophole after loophole after loophole. And so eventually I just read thousands of pages of legislation to get to this point. But I found a little loophole that said if it's a yacht under 7 meters, it doesn't require the $20,000 of surveyors and stuff like that. Small little tiny loophole only accounts to yachts between 4 to 7 meters. So I bought a yacht, put it on there, and did that. And covered all what we call AMSA, or the marine side of it. But then we're obviously operating on the Great Barrier Reef, so we have to cover the Great Barrier Reef side as well. And there's a group called GRUMPA, Great Barrier Reef Maritime Authority, that runs all the Great Barrier Reef. And they've got a reputation of being very, very difficult to work with. So I knew I was up for a challenge, but I knew I had a system that did less damage than a snorkel out on the reef. And so I knew I was coming from a good spot. I knew I could get it through. I just had to convince them. So I submitted all my stuff to GRUMPA, and they say, we'll take 1 month, and then we'll get back to you with the yes or no. 10 months later, they got back to me, and they said, here's your permit, you're good to go. And I read my permit, and my permit was completely blank. On the bottom page, it said, other use, and that was it. I waited 10 months for it was 15 pages, so they're all basically blank. In the last page, it says, other, anything you want. So I was like, I said, well, that's not what I asked for, but that covers what I want to do, so I'll go for it. And so about a year later, we finally finished everything. We got to the stage we were ready to launch, and we did. We launched, and we got a lot of advertising out there, spent about $20,000 in advertising. We got a lot of free media, and we started to get the users growing on the platform. We started to get up to about 400 users straight off the bat. And then I got a call one day from GRUMPA. They said, hey, we saw your drone out there the other day, and we're just wondering what you're doing. And I said, well, I'm doing what I permitted to do and what I explained I want to do, and you've got to be a permit here all this. And they said, okay, we'll get back to you. And 2 weeks later, they called me up and they said, you need to remove it right now. You're not covered under other. Other doesn't cover this. And so I pulled it out. And then I had to refund 400 users, obviously, because we didn't have that anymore. And then they just ignored me for about 6 months. They wouldn't reply to emails, texts, nothing. I was just dead in the water. Nothing I could do. And then eventually, after calling every single day, I got a hold of a lady there called Sam, funnily enough, who had a little bit of heart. You could see, go, oh, hang on, like, he's not really out here to, he's trying to do something good here. Let's see what we can do. And I worked with her for another, it was 11 months in total, before I got the permit back. And then they gave me the permit back that said other again. And I said, no. Let's go and write in exactly what I'm doing there, so this doesn't turn around and happen again. And so we've got to wait another month or two. We wrote that in, and then we eventually got past it all. But I thought I'd just put that in there of just like, no matter how many things you think you've solved and you think you've got a straight path, there's always someone else who holds the keys. And you've got to be very, very careful to make sure you have enough runway and enough stuff to cover little things like that, big things like that happening to your business, because we're still recovering from that, 2 years later, basically. But James Cook University came to the rescue last year with their Impact 10X. And Sam graciously invited me to come along, and I was working with part of my team, we're a whole heap of IT medical people down in the Children's Hospital. And I came up with this great concept where I was like, hey, these robots in pediatric hospitals, this would work. This would be a really great place for it. And so with the Impact 10X, I was grateful enough to win first place, and then got some money, and got some prize money. And I was able to put that prize money straight into the Ocean Escapes program. Once again, you've always got to find a partner. So found a partner with Starlight Foundation. And so we've been running for the last 3 months, having 11 different locations across Australia, have pediatric patients in their beds on an iPhone, on big giant screens, whatever, controlled and involved in out on Green Island. They've been driving around. They've been having a ball. It's been actually gone amazingly well. They spend 6 hours or more every day just driving around. And so that's been kind of a saving grace out of the whole thing. And so we're working towards trying to make this a permanent program. Starlight really wants it permanent. We've just got to find funding to make it keep on going. It's always about that. So it's always, you can make this all in your garage, but eventually you will need money. And so that's what it all comes down to. Okay, so that's a story about me, Teleportal, AussieBot, how we got here. Now I want to talk to you about the future of marine AI and robotics. And I want to go through the key bits of technology that we use to familiarize yourself with these sort of things. So the first off is the Pixhawk. And this is the very first version. And I still use the very first version today. There's lots of different versions since then. Very, very cool. That's your autopilot. Then you have your Raspberry Pi, your single board computer. That's the brains. That's what you're plugging in data and cameras and stuff to. And then also, I thought I'd point these two out. So that's the Blue Robotics. Great company out of the United States that sell really cheap underwater parts. So normally when you buy underwater parts, there's like $10,000 for one little thing, because that's how these companies roll. This is the company that sells it for basically just 10% above cost. And so you get stuff very, very cheap, and they're very well engineered. And I can attest to that because 25,000 hours on it, it's doing pretty well. They also last year released a boat version as well. So you get a boat. So instead of having to build something completely from scratch and completely design it, although that's a lot of fun, you can go to a company like this and get the parts. And what I like about Blue Robotics is that this doesn't have to be the design. You could build it as an autonomous vehicle like a torpedo or something, but it still uses the same lights, the same electronics housing, same batteries, same, it's all the same. You just put it in what we call a different frame, different order of how you put it, or you can put it in a boat as well. So I seem to have got stuck. There we go. But the biggest advance since I've been working on this for the last 5 years is this. Does anyone know what this one is? Sailing. So all these things where we had boats in the middle of the ocean, or even on the Great Barrier Reef, it doesn't have to be the open ocean. The problem was always communication. Trying to communicate with these things, we could get text messages through satellites, and that's about it. And then this one came along, and this changed the game. This totally changed the game for marine and robotics. Because before, our communications were text message based, and there's only so much you could do with that. And it limited a lot of the technology you can have on the boat. But now with Starlink, we've got internet beaming straight from that boat out. And that is a huge, huge thing. Now, we suddenly have photos we can send back. and we can get a live picture of what's going on. We can get videos, we can get a live video stream. We can get the entire data set, not just the last point. This really changed everything. Okay? And it's only a couple of years that it's been happening, and already it's just changed the game. It's allowed these things to become prevalent. These are the suicide drone boats out of Ukraine. And these are Starlink. This could not happen without Starlink, because if you're trying to remote control this without an image coming back, you wouldn't be able to remote control it. You wouldn't know where the ship is that you were trying to aim for or anything like that. So the Starlink is what changed this, because the rest of this boat is basically a standard Aussie bot vessel like the one that I sent around Antarctica. What's inside it is exactly the same. The controllers, the Pixel, the Raspberry Pi, they're all exactly the same. All they've done is they've added a Starlink and a camera, and that's allowed them to have an amazing device, which, although, you know, I'm not into war and stuff like that, what it can do compared to, you know, this little thing that costs less than $100,000 is destroying something that costs $100 million. And so right there, it's a lot of bang for your buck. There's also Australian version as well, the blue bottle, as they're called. And these guys were doing, just starting as I released Aussie Bot in 2019. They're now a $300 million company. Yeah, massive. And they have a fleet of about 10 of these off the coast of Australia right now. But what's going on in that blue bottle? Solar panels, battery inside, Pixel driving, Raspberry Pi is the single board computer, and that's it. And they've recently put Starlinks on last year, but that's it. It's the exact same thing, but now $300 million company. So this is the future. This is where everything's going. It's just like the aerial drones are kind of where everything aerial is going. Ocean drones is where everything's going, because instead of spending $100 million on a big ship, you can just spend 100,000 and pretty much get the same data from it as well. All right. So the future of marine AI and robotics, the biggest thing, advancement that has happened in the last few years is ChatGPT. I can't stress this enough. The months and months of trying to solve one little tiny problem, how do you link these two things together with Stack Overflow? Now I can fix in under a minute with ChatGPT. I literally just ask ChatGPT, how do I put that camera into the Raspberry Pi and get the image out of it? And it goes through step by step and will explain it to me in endless detail of how to do it. This is huge. This is huge. And so for you guys who want to get into AI and robotics, I can't stress enough, you want to be using ChatGPT all the time. I spend most of my days in a constant conversation with ChatGPT. It's explaining stuff to me, it's writing my code for me, I can't stress enough.
Hallucinate much with your topics?
Sorry,
Does it hallucinate much? Are you seeing?
that was my next point.
Yeah.
So my next point is, it will tell you confidently, here's exactly what you need to do. And what I always recommend is test it. Obviously, don't just trust it. Test it, see if it works. But also, don't be afraid. And this is what I do a lot. Is I'll have a quick little skim through, and I'm like, no, I think he's hallucinating. And I'll just ask ChatGPT. I'll say, could you be wrong? And it will come back and go, yes, I'm wrong. Here's how I'm wrong, and here's how I'm fixing it. But you had to ask.
Yeah.
You had to ask ChatGPT, are you wrong? And it will go and self-assess. And so I always go, hang on, that's great. How could you be wrong? And it will go through how it could be wrong and what you should be taking a bit
So
closer.
your exact prompt is how?
Show me step by step how to control a remote control boat via a web page using a 4G modem, a Pixhawk, the autopilot, and a Raspberry Pi. And it will tell you step by step of how to connect that remote control boat into the Pixhawk and how to connect the Pixhawk into the Raspberry Pi. And then it will tell you how to build a web page using Nginx. And it'll build the web page for you of you to control it as well. Okay? Step by step. Now, I might not give you all that in one prompt, but then you can go, show me step by step. It'll outline everything that you want to do. And then you go, okay, step one, explain that in more detail. And it will explain in far more detail step one of how to connect that one thing to this. And it's just scouring all those how-tos out there and bringing it all into one place for you. So I can't stress enough.
Give it a try now, as Adam
Yeah,
has tried. Give it a try, especially Mark. I know this is your field. He's going to be big in robotics.
I
And so
can't stress you have this huge leg up. What took me years to build, you can build in a weekend, basically, with ChatGPT, because it does all the research for you. So I can't stress that enough. You want to use ChatGPT and you want to be having endless long conversations with it. When I'm working at home on coding, it's a ChatGPT on one window and one working, and I'm constantly asking back and forth. And the other one piece of advice I'll give you is that when it tells you to do something and run a piece of code, run that piece of code, and then the output that comes out of that code, you know, all the errors or whatever's come up out of it, copy and paste all those errors and just shove it straight back into ChatGPT. Don't even tell it anything, just shove the errors. And it will fix those errors one by one until it gives you good code.
We can just plug the screenshot in.
Sorry?
You can plug the screenshot in as well.
That's it. There's many different levels to it, and you can get, you know, specific AI agents. But anyway, okay.
Anthropic, do you use Claude or not? Or is it just ChatGPT?
I push people towards ChatGPT. There are other agents you can go down that are even better. But what I like about ChatGPT, as opposed to going for a specific AI code one,
Yeah,
is that I'm asking questions about hardware a lot of the time and how they connect together. And the code one's not so good at that, but really good for code. ChatGPT is kind of in between. All right, so the future of marine robotics, we've already explained the Pixhawks in everything and the Raspberry Pi or some other similar single board computers and everything. And these are the two that we're kind of adding on. And this is the future coming in the next few years. So we're adding in a TPU, that Coral made by Google, a tensor processing unit doing over 1 billion calculations per second. We chuck on a USB camera, and then we can also chuck on more advanced sensors as well. This is a Doppler sensor. This is like GPS underwater. So everything above water, you just use GPS, you know exactly where you are. When you're underwater, you can't use GPS, so you get one of these. And this is sending out lots of signals underwater and getting signals back, and it can detect it's moving across the bottom of the ocean, and like a GPS tells you where you're going. So the Pixhawk. If you ever build a drone, you're going to have to get to know one of these. Very, very simple. Inside it is very simple. It's a very small computer chip, embedded chip. It's very, very simple. And technically it's using AI, but it's using a very simple type of AI called a PID system. Anyone heard of a PID? No? Okay. PID is this particular thing here. You plug in at the top here all your servos and motors, stuff like that. You plug in here your computer to one of the telemetry spots. You can add in power, I2Cs like serial, off to your sensors and stuff like that. So you can plug everything in, your GPS, all that in here. It has inside of it a GPS, an accelerometer, a magnetometer, all the standard sensors you need for a drone. And then what it's doing is you're saying, here's a bunch of waypoints. I want you to go over there. I want you to do these certain things on the way there. If you're a marine drone, I want you to go underwater to this depth. If you're an aerial drone, I want you to go to this height. And then what it's doing is, as it's going along, it's just using PID, which is just a constant program going over itself, going the p-value. So you've got a whole heap of parameters that you can change on this. And that changes it from a rover to a boat to an aeroplane or whatever you're doing. And then there's a whole heap of PID values for pretty much everything that it can do. And you just adjust these and then adjust how it drives. And so you adjust the first one, which is P, which tells you to steer back when you drift off. More drift means more steering. So the value of that P determines how hard it tries to steer back when it goes off course. Then the I value reminds you, if you've been off the path for a while, asking you to correct more. So that's the value. If you've been going off course for a while and you keep trying to get back, but you're never quite getting back, this is going to make sure you turn sharp and you get back to where you're meant to be going. And then the D value, the derivative, calms you down if you're wobbling too much. So if you're constantly going left and right, and you see that, you adjust this value and that calms down how it turns left and right all the time. Together they help you ride smoothly and stay on the path. That's what's going on in the Pixhawk control. It's quite basic, but actually the math in it is very, very complex. But once you understand PID, you just constantly change these values until it goes in a perfectly straight line and you've tuned your vehicle. Then data collection. How do we get all the data that we want? Because that's the idea of this. We don't just want to have a remote control boat out there. We want to be able to get data from it. And this, once again, I just use ChatGPT. Everything. So all these sensors that we have, whether they're like sonar, this is side scan sonar, depth, pressure, all these sort of sensors. The majority of them these days are USB. And so you just plug them into the Raspberry Pi, and then you go to ChatGPT. I want to get the data from this type of sensor via USB to my Raspberry Pi. I want to store that data in a database and display it via a web page. Show me how to do it. And it will. It will literally show you how to do it. When you say, oh, it's this particular type of sensor, it'll get the data sheet, it'll work out how to get that data out of it, and it will go make a database and put it on a web page and display it for you. And then you can just log in and see it all there.
Will it give you data? Will it give you a certain amount of synthetic data?
It'll give you whatever you tell it to give you, basically.
Okay,
Now, one thing, okay, that's progress as you go down that prompt, a little bit more advice.
yeah,
As you go down that prompt, what I generally do is I break it up a bit. And I've tested that prompt, it does work, it does exactly that. I break it up and I go, hey, I want to get this data from the sensor via USB to my Raspberry Pi and just print out the raw data. And so I can see all that raw data coming down. And I go, oh, the value of 3, that's what I'm after, that's the distance value, 3 meters away, that's what I want. Then I copy and paste that raw data into ChatGPT and I say, see that value 3, that's what I want. Save that to the database and show it in your web page, and it will do the second half as well.
wow.
Because sometimes you don't, it might hallucinate a bit of which part of the raw data is actually what you want. And so that enables you to get to exactly what you want. But for all the sensors, you just tell ChatGPT what type of sensor it is, and away you go. The only thing you're going to get a little bit stuck up in is that not all sensors are USB. A lot of them are serial, or what they call SPI in most of these things, which is just serial interface. USB is universal serial bus. There's actually everything serial. There's just different versions of serial communication, but it's just ones and zeros going down a wire. That's all it is. So you have USB, you have SPI, and then you have I2C as well. And they're the 3 main kind of different formats that you can have a sensor come out with that data. But all it's really doing is printing out raw text data of this is the data from the other sensors. So really, really easy to get, store it in a database, put it on a web page so you can see it, and away you go. Data collection is one of the easiest things we do. Then it comes to decision making. This gets really complicated, and there's 20 different ways to do it as well. And it depends on how much power you have, really, on how much power you have, as in how many flops, how many CPU cycles you can pull out of it to make decisions. So most of my bots are predefined rules. You set up a series of if-then rules for a vehicle to follow based on sensor inputs. For example, if it detects an obstacle within a certain distance, it changes direction. That's what this guy does every single day. It gets a meter away, detects that, and then pushes up and away to get away from that. Okay, if-then rules. And that's 99% of robotics, that's what's happening. I also use a little bit of this, and mainly in the new one, the AussieBot 2 that I'm building, this is what I use, finite state machines. To manage different states of the AUV, such as exploring, avoiding obstacles, or returning to base, and transitions between states are based on sensor readings and other conditions. So I have, like, on AussieBot, the boats, I have like a low power state. So I don't have much power, so I'm going to turn nearly everything off and just keep everything low. I have a high power state where it's going to turn on every single sensor and do everything it possibly can and increase the speed up until the point the battery starts going down again. So you have a high state mode. You have a mode for I'm avoiding something. This has detected a face or detected a person. I want to get away from them. Okay, so I'm going to go the other way. They're the different finite state machines. That's probably, as I said, 99% of the robots out there, that's what they're using. If then and finite states is kind of the more advanced version of that. Then you go down the rabbit hole. Machine learning models would be the next one, and that's what's going on here with image detection. So you've got it's a trained model on using labeled data. So someone's gone through thousands of images of people and cars and cats and labeled each one. That's all being chucked into a model, and that model runs locally on the little TPU here, and that can detect objects from a camera using very, very low power. So this is starting to come in, mainly just video, mainly just image recognition. Reinforcement learning is probably another really big one, but I do not recommend it for autonomous underwater vehicles. Surface vessels, somewhat. Underwater vehicles, I do not recommend it at all. So reinforcement learning is, hey, we say these are the optimal behaviors and these are the bad behaviors, and we reward when you're doing well, and we say bad little boat when you're doing bad, right? The problem here is if it does something bad when it's underwater, we can't learn from it because the boat will just disappear and you'll never see it again, you'll never know what it is. So reinforcement learning in this particular case is really not useful to us because when it does something bad, we never know about it, therefore we can never improve it, we can never cut that out. And it's a bit like rocket ships to a certain degree. Once it's done, you don't know what went wrong. And so I would avoid reinforcement learning at all costs. The other two, all honesty, this is getting beyond free open source software, and this is getting into military proprietary software. And that's neural networks and fuzzy logic to a certain degree, but definitely the neural networks. This is what's coming. Those latest big giant subs you see out of the US Navy that are all autonomous, they've got neural networks. They've got giant, yes. Well, no, all this is different. This is the Manta Ray, is the latest one.
The measures, okay.
So the neural network, basically they would have like a server room filled with computers inside this autonomous vessel that is constantly doing massive calculations with AI algorithms going on. But there's nothing open source out there, and that's why I'm kind of just going to leave that one behind, because there's nothing I can show you that you can have a play around with. I can point you in the direction though. There are open source ones out there for audio surveillance. So I can have a microphone in the water listening. There's free open source ones online that will constantly monitor that audio coming in. And when it detects a boat, maybe a submarine, something like that, it'll tell you, hey, I detected a boat or a submarine, and then it can tell you back for sure. I'll let your imagination go wild with that. That's basically where everything's going on that. And so that's something you can trial without getting into the proprietary military kind of stuff. Fuzzy logic, I already implement this in a lot of stuff that I do because I have multiple sensors, and a lot of these sensors have a accuracy reading. So it'll say, hey, you're 3 meters away, I'm 75% sure that's true. And if I've got multiple sensors, when one gets below sort of 50% accuracy, I can ignore it. And that's fuzzy logic, basically, is that you've got multiple sensors and you can detect, hey, one's not right, I'm going to ignore that one, I'm just going to base it on the other one. And the Pixel already does that already. So if one GPS is not too great, but the other GPS hooked up to it is good, it just reads that one and uses the accuracy measurements in between them. All right, how many over time? I'm doing good. So, hands-on activity. This, I think, is quite amazing. This took me quite a lot of research to discover this one, because has anyone done image recognition here at all? Anyone tried to do image recognition?
We've done a lot of facial recognition.
A little bit, yeah.
Yeah.
So generally use.
Robotic arm.
Yeah.
Yeah. So they're.
And you open CV. Yeah. So most people know image recognition, open CV, which there's a lot of instructions out there. You know, you can learn it. It is pretty easy, but it's very hard for a beginner to be picking up open CV and doing it properly. And there's a lot of small settings and stuff, and it's not graphical user interface as well. So what I discovered is this thing called Frigate. It's an open source piece of software that really, you can plug in whatever image detection algorithm you want into it. You can plug in as many cameras as you want. You can plug in as many TPUs from different sorts that you want as well. And it has a graphical interface as well. And so with a Raspberry Pi, a TPU, an AI chip, and some USB cameras, you can detect the image recognition for under $250, and you can set it up in under an hour. And that, I'm sure for people who've done OpenCV, that's amazing. That's probably would take you weeks to do. Yes, did it before. So, how do we do it? First thing we do is we have to buy a Raspberry Pi. We need a single board computer. We need something small like that. Depending on the model, $65 to $120. The best one, number 5, is out there now for $120, and that's what's here. You can get them for as cheap as $65. Does anyone have a Raspberry Pi here?
Yeah.
1, 2, 3. Okay, so yeah, go. For those of you who don't have a Raspberry Pi, this is your next thing you need to buy. If you're into AI and IoT, you need to buy one of these straight away. You do. Yeah.
What version have you got, 4 now?
There are 5s in here at the moment, but 4, 3 doesn't matter.
Okay.
Doesn't matter. And I'm super excited for those who didn't raise their hand because you are about to embark on something amazing. You're going to learn Linux. You're going to learn Linux because the whole point of buying a Raspberry Pi is you tinker around with it, you look online and you go, oh, I'm going to block all my ads, Pi hole, you do that. Or it can do 200 different things. But as you cycle through these different things it can do and you can set it up, you're going to learn all the stuff you ever need to know about IoT and in particular driving a Linux machine. And that's going to open your world up for everything.
When we go on a field trip with the XUT team, I'll take them via JCal and we'll
Yeah.
get you your first Raspberry Pi.
I can't stress it enough. If you are studying IoT and AI,
Yeah.
you need a Raspberry Pi to play around with. So you set one up, plenty of stuff online, takes you 10 minutes, but you download and install the stuff onto an SD card on your main computer, and then you configure it. Most people with a Raspberry Pi, they put the software on it and they hook up a computer, a screen, a mouse, a keyboard, and they start operating on it. There's actually a really simple way to skip that. When you're actually choosing the OS to put onto the SD card, you can set it up in what we call a headless environment, where it will automatically be ready to accept connections over the network. You give it a network to connect to, and you give it a username and password, and you can just, from another computer, just kind of remote into it and control it that way. And so basically you just plug it in, leave it in the corner of your room, you never have to touch it again, you do it all from your laptop after that. It just saves a lot of time trying to plug stuff into it. So anyway, you do that, and then you connect to it, you SSH into it. Anyone know what SSH? A little bit? It's another thing you gotta learn SSH. You gotta learn how to SSH into a machine. Basically, we're just connecting to it and get like a terminal prompt that we can then do stuff and change stuff. Or just watch YouTube, YouTube videos, they explain it. So now that I know the kind of limits of what people are used to, I'm going to skip over these next few slides a little bit quickly. You get a Coral TPU. So this can detect without a TPU attached to it, but it's very, very slow. A CPU is very slow. CPU can only do 1,000 calculations a second, where this is doing 1 billion, way, way faster. And they're reasonably priced as well. They're about the same price as the Raspberry Pi. And if you're doing AI, this is kind of a no-brainer. You want an AI chip to work with, and you can use all your tensor stuff, anything you want to do normally, doing little things that you normally do, you can do it, any tensor work with OpenCV stuff, you can use the same thing. Does this make sense to anyone?
Yeah.
Once you learn a Raspberry Pi, that'll make a lot of sense.
Just a quick question, the tensor, this you said works with the tensor, but what about all the other ML things, like
Then you get a different TPU.
a different?
Yeah, this is the tensor TPU.
That's why it is, TPU is tensor processing unit.
Yeah.
And you haven't seen a way to adapt the tensor processing unit to other types of.
There are stuff online to it. There is lots of stuff online. It's just like anything, you might want to stick with one type of AI, which is the tensor stuff, but I have seen them be able to cross and change quite easily. I won't go into this, but this is basically, this looks like gobbledygook, but once you play around with Pi for a little while, this is going to come, this is very easy. This is saying, hey, this is where my program's at. I'm adding a key to make sure I get it securely from that place, and I'm installing it. That's all that is. It looks really complicated. I mean, the first time I saw it, I was freaking out. I don't understand any of that. Once you get used to it, it makes perfect sense. But basically, for you, you just copy that and paste it in. And then you copy that, paste it in, then you copy that, paste it in, and you're done. Got any problems? Just ask ChatGPT. Then we're going to install something called Docker. Docker is a virtualization system on computers. All computers use them. And what it does is it just simplifies the process of installing a new software, because you basically install the software on a mini computer within a computer. And then for nothing on your computer can kind of interact poorly with it and cause any issues. What that basically means is you can install something and you pretty much guarantee it's going to work flawlessly straight out of the box. You're never going to have to play around with stuff. And so that's why it's used for Frigate. So we just copy that command in and it loads it all. And then we just follow the instructions or ask ChatGPT and it will show us how to do it. And we want to install Frigate. So basically we just loaded our computer up with an OS. We've loaded the drivers for the TPU, for the AI chip. We've put on a virtualization software called Docker Compose, which allows us to run mini computers within our computer. And then we're loading into one of those mini computers a software stack called Frigate. And we copy and paste those commands in. And the last thing we do, it's probably a little bit more in depth than what I wanted to do with you guys, but I'll just add it is MQTT. The reason we're putting this in here, MQTT is a messaging service in between programs. So say you're running program A over here and you've got program B, and you need to send a message from program A, say Frigate, going, hey, I've detected a person, and you want to do something with that information. So you're running a Python script, program B, who's going to receive that information and do something with it, like control a relay. So an MQTT server does that. One's called Mosquito, is the one that I used, and you copy and paste these in, and it's done. That's all it is. And so Frigate will communicate with it and say, we'll send a message going, hey, this camera detects a person. And then if your app is also connected to Mosquito, it will receive that message and can do something with it. So that's our software stack. Once you've gone through copying and pasted those few things, you're done. Set up complete. You now have full AI detection at your fingertips. You log in to the web page that's on it. So most of these things in Dockers, they also have a web server that's running a web page, so you can control it using graphical interface through a web browser. And this is what Frigate comes up with. And I'll show you hands-on in a second. You've got all your cameras there, so you can see them live. You've got bird's eye, which is like all your cameras together. And then you've got events. So when it detects a car or anything, it puts an event. And you can tell it what to do. And what I love about Frigate, it's not a matter of choose these settings. It's got a massive configuration file that you can just keep adding stuff to make it do pretty much anything you want it to do. And so with these events, I've currently got it set to sends a message to the MQTT server so I can do something with it. And then also takes a picture, or you can tell it to take a video, or you can tell it to send you an email, any of that sort of stuff. And then configuration and logs and stuff like that. What I also love about Frigate is it's completely free. Download it, enjoy it if you like. Great open source community behind it. But they also have this thing where you pay $50 a year, and through that app, you can upload pictures and you can get it to create up to 12 models per year for that $50. It'll create a whole new model for you based on what you want to detect. So you can go in and set your camera up somewhere, have it recording, and then you detect the whole heap of zebras, which it doesn't detect. It only detects cat and dog, but it doesn't detect zebra. You can upload those images to the platform there. You can select zebra, zebra, zebra. It will compute a whole new model for you that runs locally on the machine. And then you can download that, put it on your local machine here, and it will run an AI detection that is specifically set up for not only this hardware, but also where your camera is located and the pictures that you see. And so I'm doing this at the moment for boats, loading different boats into my boats. But for $50 to get 12 models, that's just ridiculously cheap in the grand scheme of things. And you can do it yourself, it's all open source, but they have a service that I think is just like a no-brainer if that's what you want to do. Do you have to do this? No. Out of the box, it detects like 20 different things. You don't need it, but this is just somewhere where you can go for what you're doing. I've just explained, instead of spending years on OpenCV trying to make your own thing, we just put a stack together in 1 hour, and now we can configure it in another hour, and it will do exactly what you need to do, basically.
This will be good for the Smart Mirror project guys when they get into the human machine space.
So obviously, I didn't expect any of you to remember anything that I just said in the last 10 slides. So I put a QR code there's a GitHub page where I put all the instructions there for you.
We love you, Adam.
And you can, I mean, you're going to buy a Raspberry Pi first. You don't have to buy the TPU straight away because you can do it without a TPU. But that's something to play around with. And you will be years ahead of everyone else because I haven't seen anyone talking about Frigate and how it's set up to be, it's designed to be just a security camera software. That's what it's designed for. Security cameras, plug in as many security cameras as you want, but it has this configurability where you can put in different AI models. You can split the screen into a whole heap of different zones and only trigger for the different zones. And you can tell it not to look at stuff, look at stuff. And you can change all the weightings as well. So if it's detecting people, it's ghosts, it detects ghosts. I turn down the weighting of people a bit and it will stop detecting ghosts. And you can just control everything. And that's what I love so much about it. Everyone got that? Beautiful. All right. So to finish up, here's one I prepared earlier. So we went through it before, but just to run through what's going on here, I'm going to take that off so that it will detect someone. There it goes, detected someone. So we have two cameras up here. We have the Raspberry Pi single board computer here. This is its power coming in, and then this is also an I2C connection to the relay board, serial connection to the relay board. And then the lights connected to the relays as well. And then we've got the TPU flashing way up the top here. And so to run you through what's going on, this single board computer is constantly taking 5 frames per second from each of those cameras and bringing it in and sending it to the TPU, who's analyzing those images and looking for people and books is what I've currently got it set for. When it detects those person or a book, Frigate sends a message via MQTT out to any other program that's listening. Hey, I've detected a person on camera 1. Now I have a Python script running continuously on the Raspberry Pi, which is kind of my effort in this equation, which ChatGPT wrote the whole thing. Don't get me wrong, I didn't write anything. ChatGPT wrote the whole thing for me. It's receiving that message and going, hey, there's one person detected on camera 1. I'm going to light up. I'm going to turn relay 1 on. Okay? And when the number of people gets to 0, it'll turn it off. And the same with book on the other one. So these are 2 people that it's seeing currently. And then if there was books, it would be the other 2, but this room doesn't have enough books in it to detect. And it's not just like it's detecting people, but you're all the way over there. It doesn't have to be right in front to actually detect something. So what I might do is I might just pull up the back end so you can have a quick little squiz of what I mean going on.
So you were also, so this is a really great example Adam's given you because Adam's self-taught, but you didn't go to university to learn this. Oh, wow, look, it's taken all of that.
So
Oh, wow.
I'll explain the stack at the moment. This Raspberry Pi is connected to my phone Wi-Fi. And my laptop is also connected to my phone Wi-Fi. And because they're both connected, I can talk directly to that Raspberry Pi. I'm on the same local network. And so I've gone to the IP address of that Raspberry Pi and gone to port 5000. And that's a web interface for Frigate behind the scenes. So we've got the 2 cameras there that it's currently feeding from. And then when we go into events, these are the ongoing events that are currently happening. And so what I love about this, you can download the picture if you want.
Yeah.
Here's what had happened, how many seconds has it been going on for, which camera, and this is how sure I am that it's a person. And you can adjust that as well so it doesn't falsely dictate or however much you want. And you can see it hasn't just gone like there's a person in front of the camera like most cameras do. It's gone around and go, hey, that's a person, 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 way in the background. A lot of the time, if I hold up a book that's got a person on it, it'd be like, oh, there's a person in that book. It goes really, really much in depth. And it's got trigger after trigger after trigger. And then as soon as if I, unfortunately it doesn't work fast enough to really be a good demo, but if I block both of those cameras, all those ongoing events will eventually shut down. It's just got it has to take a minute or 2. There we go. There's one gone. And all those events will eventually disappear. There we go. Both cameras are now detected. And all those, if I could go over and refresh it, will be in past events and they'll no longer be ongoing. And that's something you can just go back and have a look at, obviously, like a security camera. And last but not least, they should flick back on. Boom, boom, boom.
Yeah, yeah, both on now.
You can export all this data as well, which I quite like. And then I like also, I just love graphical interfaces. Because normally with all this, you'd have to be going through the, code basically to get all this out. But here, I can tell that here's my TPU, Coral. It's doing it only takes 15 milliseconds to read a picture and output whether there's a person or something in it. So it's doing quite well. Raspberry Pi 5 doesn't have a GPU. And then the camera's there. It's recording at 5 seconds on each one. You can adjust that. That's what I've set it to, 5 seconds. And it's capturing it and it's detecting it. And then probably the biggest one, which if you do set this up, you'll spend a bit of time in, is right here, is you can change all the config. So there is the config file that I'm currently running. And you just ask ChatGPT. ChatGPT wrote this whole thing for me. I don't understand any of it. It just wrote it for me. So there's the MQT server that it's connecting to. So it's going, hey, I'm going to send messages over here. It's going, hey, detectors, CPU. I've got a Coral and it's plugged in by a USB. I've just set up to take a picture every 90 seconds anyway from all cameras, recorded them. And then each camera, you can put in all these different configurations. So I can tell which camera is it, and I want to detect, record, and also be able to have a look at live view. And then I'm going to detect, am I going to use a small frame or am I going to use the whole frame? I'm going to use the whole frame. I'm going to do it 5 times per second. What am I going to track? I'm going to track people and books. There's 30 other things you can put in there. And then back your next one going down. So you can just change it around. When you have this fully set up for something with a robotics setup, this would be quite long because you would have, I'm going to split each camera into like 4 different sections and I'm going to consider each one of those as different. I'm going to have different weightings of people because I want to detect everyone or I want to not detect unless they're really in front of the camera. Lots of stuff like that. You can go in and do endless analysis of it. But yeah, that's the basics of it, which I think is pretty cool. So that's the end of the formal presentation. I'm sure I've still got 5 minutes for questions, maybe.
Thank you so
much.
Check online question.
Sure. Do you have any questions out there I can start off with? I'd love to help you out with whatever you're working on.
Maybe we have a question. So we are with that guys developing a project with digital agriculture, and we basically put sensors in the soil, and we are using LoRa to detect that. But in digital agriculture, one of the techniques they are using drones to detect, different temperature or whatever. And you say in your presentation that it's easy to build the drones with this type of technology that you can. So it's possible to instead of, so my question is more focused, is better to try to build a drone like with or better to buy the drone from DG?
Yeah, it's the endless question in these kind of things and you got to do a lot of research at the start to work out which way forward. And it's not as clear. It never is. So whenever I'm building something like this, my research starts with what can I buy off the shelf that I can then modify to do the same thing. And I start that way. And then when I get to that stage and I price that and I go, how much would it cost to build it myself instead of buying the base unit? The great aspect of always going with building yourself is it's fully customizable. You go get a DJI drone now, it will do 5 different things, but doesn't do the 6th and 7th thing that you need to do for your project, maybe not. And it might not have APIs that you can access. And that's where building your own one. The great thing about the DJI drones and all drones is they're all based on the Pixel, which is actually all based off of NASA. It's actually a NASA project that was done in the early 90s. And it went open source and they just kept on running with it. So what I would do for you guys, my advice would be would be to start researching first person view drones. Because they're all home built. People don't buy them, they build them.
Yeah.
And they're all based on Pixel. And you plug all your motors into it and go through instructions on there that are 200 different versions of instructions there, pretty well documented. Build it yourself, and then you have the ability to add on stuff to it. So you can add on some processing unit, maybe a Raspberry Pi to do the processing in the air. So what you're doing with agriculture, the most common thing is they buy a DJI drone, they fly over it, they record all the video, they bring it back to the lab, they go through the video, they use big computers to sift through it, analyze AI, and get some data out of it.
Yeah.
But I imagine what you guys probably going towards is you want to be able to get that data immediately. You want the drone to do the calculations for you. And if you want the drone to do the calculations for you, then you're going to end up with a system very similar to this. You're going to end up having to need a TPU. The Coral TPU is the exact one that you use. And you'd have a Raspberry Pi to kind of talk between the autopilot, which is Pixel, and talk between the camera and anything else that you've got going on, basically, and bring all that data together. But with the TPU, your drone would have the ability to run a local AI model and be able to detect stuff and tell you, the user, or maybe come back and circle in closer or whatever it needs to do before that. So I would first investigate, hey, does the DJI drone have a big enough API I can do this? It will take less time to buy it off the shelf, always will. Cost a little bit more money, but it'll take a lot less time. Or am I going to build it myself? And it sounds scary building a drone. There is 10-year-olds building them right now, all the time. It's like it's not hard to build a drone platform. It really is. Too many people have come before you and done too much documentation that you can easily build a drone yourself. I would start with an open source model. I wouldn't try to design it myself. I'd start with something that you see flying on YouTube channels, build that exact same thing, and then start adding on the systems that you think you need for this agriculture stuff, which to me would be a Raspberry Pi and a Coral TPU. And your biggest concern is weight. With an aerial drone, you just got to try and get the smallest possible thing you can get.
Yeah.
And so, but you can do that with it's smaller. Yeah. Is that kind of answer?
Yeah, that makes sense, because we've got eyes on the ground now with IoT engineering, sensors, humidity, temperature, CO2, what else have we got?
pH.
pH, haven't got much to, but it's like eyes on the ground and eyes in the sky, right?
Yeah, it really comes down to what data do you want to get from that drone while it's in the air? And based on that data that you want to get, would be where my advice goes of how you get to that data. And if it is image recognition, then you're going to have to go the TPU way. Basically, what I've just shown you here is exactly what you do. That's the easiest way to do it.
There's your recipe, the formula.
Yeah, because I was
Yeah.
curious one time ago about digital agriculture and I looked at drones.
Yeah.
But I mean, because a drone for DJI for agriculture, 1 million, that's a lot of money.
But they're carrying a lot of weight because they're carrying pesticides generally, or the agriculture drones, but yours is more data.
More data.
So
But
you
it was
can
done
small bit.
because I don't know at that time, like 5 years ago,
Hmm.
and they use different cameras with UV.
Yeah.
But no, I say no way.
Basically, the biggest difference in the last few years that will change for you is you used to have the drones go record the data, bring the data back, analyze the data with big machines, and then come out with an output. Now, you should be able to do that processing on the actual drone, because we have low-powered TPUs now that can do all that processing. So instead of having a big giant 4060 NVIDIA GPU doing it all, we've got this little tiny chip that is kind of doing the exact same. So there's a question over, yeah.
Yeah, question the thing we're doing is that to target the robotic arm. And have you ever built the model in your PC before you build the robot? So
Oh, okay, yeah.
yeah, my question is that when we build the model in the PC, in the laptop, so we want to connect it to the Raspberry Pi.
Mhm.
Yeah, but it's the every function. I'm very nervous about the function is normal when we connect it from the PC and to the Raspberry Pi. I believe it problem.
Explain that a little bit more. You have an issue between connecting the PC to the Raspberry Pi?
Yeah, but because the thing, the function in the PC is normal, as we test. But if we connect to the Raspberry Pi, it's because it's just it's a single computer, right? It's all the things is normal, it's good, in your machine.
Yeah, I mean, I'm constantly, on a daily, I'm connecting to a handful of Raspberry Pis all the time. I SSH into them, which means that I basically remote into them, and it's like I've got the terminal on that Raspberry Pi, but I've got it on my PC. That's how I communicate with them back and forth. And you can also preliminary use a thing called VNC, which is like a graphical version of that, where you get like the full desktop and mouse, and you can move around and just per usual. But I've got no problems connecting between a PC and a Raspberry Pi. That's what I would. You just follow the instructions on Raspberry Pis, and it will become very easy how you connect to them. But I can't stress enough, SSH is the easiest, flawless way to do it every time. So just get ChatGPT, how do I SSH into my Raspberry Pi, and go from there. If you're talking about sending data from the Raspberry Pi to a PC and stuff, I always go IP. So you can just connect it like serial, a direct connection, you can get data that way. But I generally go IP. So I will have, currently with my robots out there, I set up webhooks. Fancy way, basically, I'm running a web server, and when it gets a message sent to it, it goes, boom, I'll do A, B, and C, and it sends back a return message. So if I want to transfer data, a message in between the Raspberry Pi and my computer, I use that. I basically webhooks, or there's plenty of other ways to do it. But if I just wanted to like change code on the Raspberry Pi, I use SSH to get it every time. That's why you need to buy a Raspberry Pi. You need to buy a Raspberry Pi because the first thing you have to learn is SSH. You go on from there and you learn more and more things to go down. All right. Is there any other questions out there?
There was one.
Yeah.
I can just say that with the connection, some people build things using MCUs, microcontroller units. And the MCU tends to have a lot of proprietary
Yes.
and custom code and hardware interfaces. The MCUs are excellent. If you were making a satellite, you might use an MCU so you can get absolute control over all of the aspects of it. But what Adam's using is SBCs, single board computers. So the two things are the MCU and the SBC. So the SBC is really easy. These
And open source.
yeah, and open source, yeah. So the Raspberry Pi is an example of a very easy to use, accessible, single board computer, an SBC. But some people with very large budgets and strict security needs might go to the MCU, the microcontroller unit, and build their own circuit board. So they make their own computer using the MCU as the base.
More expensive and proprietary, so you constantly get stuck. The company's got to tell you how to do something because you can't read it. Where open source, you can get the code, you can change things if you need to get new features that don't currently exist. And I just can't stress enough, for any AI or IoT student, you want to have a Raspberry Pi to play with because it's going to teach you Linux. And once you learn Linux, all your AI stuff and all your IoT is all done on Linux. So once you can drive a Linux computer, which is what is a Raspberry Pi, you're 90% ahead of everyone else. You literally, you can run Raspberry Pi, and with ChatGPT, you can do anything. Anything you think is possible with that, because all open source and you can just change it. As soon as you go down proprietary ways and stuff like that, it gets harder and harder and harder to do that sort of stuff. So I can't stress enough, that's the takeaway message I would say, is get a Raspberry Pi and start playing around with it so you learn Linux, you learn the commands of Linux in your head, and that's going to make it when you come to a project which is like, I need to do this AI thing, I need to do this, you go to GitHub, there's a free open source where someone's done it before, and you literally go git install that into here, and it works. And away you go, and it just saves you so much. All right.
If you mind,
Oh, yeah.
One more question, two questions.
So it's all that.
market.
So you don't use an RTOS, a real-time OS. You're more comfortable with Linux on the SBC. Yeah, it's down to RTOS on the MCU. For example. Yeah, is that because all the other stuff, the hardening, the making it physically complete, the making it waterproof, the making it reliable, scalable, cheap, is all of that taking away from the time that you would use to use an
I
RTOS?
didn't supply in there. I didn't go that way because they would fit. FCUs are always a little bit bigger. To get it to the size to fit into here,
Yeah.
the Raspberry Pi and Pixel, pushed on top of each other, are the only things that fit. Where the MCUs were always a slightly bigger footprint.
It's also faster, isn't it? Because all the software is modular, so you can assemble something quite quickly.
Yeah.
And you don't lose as much time on the software, so you can spend more time on the hardware and the ruggedization.
And I always start from an open source project. I find someone who's done 90% of what I want to do.
Yeah.
I copy what they've got, I fork it,
Yeah.
and then I start adding on the features that I want beyond that. I never start solely going, I'm going to start from scratch on this. I always find someone or something that had done 90% of the work, which Blue Robotics already had. And then I just had to add on chucking over the internet, controlling it with some else.
And even with all of that modular, pre-done work, you still find yourself very busy trying to get something completed, and it still takes years.
Yeah, it still takes a long time, but that's just me.
And now it's sped up because of ChatGPT. It's
Yeah.
faster.
Chad, if I did this, what took me 2 years to do teleportal at the same time, coding wise, I would be able to do in 2 months with ChatGPT. That's the difference.
Wow.
It's astronomical. I would get stuck on a single issue on the code stack for more than 2 months sometimes. And I'd be endless trying to work it out. And these days I just ask ChatGPT and go, that's the answer. And you copy and paste and you're done. All right, thank you very much. Appreciate it.
There was a question on the solar piece, but I'll get you Helen with Jack actually.
Yeah.
How solar, how does the solar, how do you control the solar? Because you mentioned solar powered.
So-
It integrates into the entire.
So in the entire system, we have a whole heap of solar panels on the top of the boat that this is attached to,
Yeah,
and they're charging a big battery bank system. And then we have solar controllers which take that light and put it into the batteries and don't overcharge them and stuff like that. And then I have a Raspberry Pi out there that is monitoring the different voltages and also has another relay board like the one that I have here. So that Raspberry Pi out there, I communicate every day with. It has a lot of automated scripts that do stuff automatically for me, but it turns off the robot and the security cameras and the Starlink internet stuff all via relays on there. So in essence, all the solar or basically the control of the system out there is all controlled via a Raspberry Pi that has a 4G network. So even if I turn off Starlink, I can still communicate with it and go through there. So when you do research on Raspberry Pi, it's very easy to plug in different sensors so it can read amperage and voltage and it can know what's going on. And from that, I just have automated systems. When it gets too low, it turns everything off. If something stops communicating, it sends me an email saying that something's communicated. So I have a little Raspberry Pi that's controlling everything out there on the surface. And then because I'm me and because I'm so far away from it, I have a second one out there that is basically me in essence out there as a backup. So that if everything went wrong, there's another little computer I can log into that's like me being out there and I can troubleshoot if I need to. Hope that answers.
yep, the thumbs up.
Thumbs up.
Yep, excellent. Thank you so much again.
My pleasure.
This is so relevant for the team because we've got multiple projects around image detection, also back-end AI, GPT assistance. So
I'm glad you guys are in Open CV because then you can see
Yes.
to
Yes.
save yourself a year's worth of work.
yeah.
I'm using that one instead. Which is much easier.
You want to get a photo, Adam?
Lots.
With the team.
Team. Hey, my pleasure.
Let's go with the bots, guys. Yeah. You want to
Don't drop it. Don't drop it. All right, you guys spin around. That's front, yeah. There we go. All
我操，不是，哎，我站那儿，不是你这么高吗，兄弟？哦，
That's like, yeah.
没有跟直接后头。
Great. 1, 2, 3. Aha. I say, aha,
right.
aha. Awesome. You get the best one.
Okay.
OK。
Great job. So good to see one actually out of the water.
It's going back in a few days.
Yeah. Is this Bob?
This is Bob.
Oh, hi Bob. See you.
See you.
Oh, guys, yeah, so I'll see you lunch, after lunch on Monday.
Yeah, okay.
Because you've done a lot of extra work. I will see you, you can have rest in, rest in for Monday. Rest in, good. And I'll see you after on Monday. So well done, good week, good week. Yeah, all right, see you next week on, and I'll give you updates on our field visit. All right, ciao, see you, bye bye.
In,